G'day there, you're watching the Aussie BIM Guru, and today we're running through a Dynamo tutorial, and today we're dealing with tagging all in view using Dynamo. So I'd like to thank Sharon for her work on this one with me. So she helped test and also request some of the tweaks that I made to the script, so I couldn't have done it without her, so much appreciated. So we're using a family as our reference today, so what I call a superfamily, which is basically a collection of elements. If you want to learn more about how to build these superfamilies, feel free to watch my tutorial called Making Super Rooms, Room Families in Revit, published in the 10th of May 2019. So tagging, we've probably all been there before. It's very, very boring. And Dynamo is great at replacing boring tasks with automatic workflows. So surely we can tag all. So we're going to look at three parts. So today we're just tagging all in view, and we're only tagging elements that are valid to our data that we're tagging. So that's the difference between the standard tag all and what we're doing today. The second part, we're going to look at tag all in view by room. So we're going to limit what we're tagging to a specific room. That way we can look at things like room elevations and tag just what's inside the room itself. And in the last part, we're going to look at the same script, but we're going to add a user interface on the end where the user has the option to filter out certain families from what they're about to tag, just in case there's something that they don't want to tag. Say there's like an outlet within a desk which is behind the desk, so we don't want to tag it, for example. Okay, so we're not going to be using keynotes for this script. Unfortunately, the keynoting isn't available in Dynamo or the Revit API currently. So we're going to be looking instead at multi-category tags, which I actually usually recommend over keynotes anyway. The trade-off of losing a keynote schedule or keynote legend is not as big as having to work with 2 pieces of data per keynote. So I highly recommend you consider this workflow as well. So we're going to be obviously using a tag all function, but we're not using tag all. So I guess why is the question you probably ask first. So I guess one of the major reasons that we would not use tag all in this case, because I'm using a multi-category tag. So this multi-category tag is basically built to pick up a shared parameter that I've specified. So it's my Aussie BIM Guru data code parameter. And essentially all the families in this view have this parameter. So this chair, for example, has this code. You can see there it's got a f.cha001 as its keynote driving this parameter. And that's what this tag pulls out as a result. If I actually try to do a tag all using this multi-category tag, it will go and tag everything that it can, but the problem is it'll tag everything it can. So it'll tag things like walls and doors, which we don't want. So because we don't have valid parameters information in these elements, so we don't want to go and tag all these elements because that can be a real pain having to go and clean up all these question mark tags. Or there's particular categories that you never want to tag with certain tags. So the way we're going to build this Dynamo script, it's going to behave like a tag all function, but it's going to have a lot more control than tag all. So I'll just go back a step. And obviously today's function won't be able to place tags as neatly as we usually would, but it saves at least half the clicks that you'll do whilst you're tagging. So we're going to use Dynamo to save us from at least some of the boredom of tagging, but not all of it, unfortunately, because it's hard to build a script that can place every tag in a good location, because obviously every element's different. The orientation of tags is always made to fit the white space, and that's always different in most scenarios. So we're going to be using some custom nodes today. One of them is the all view dependent family instances of category from Clockwork, and we're going to be using that to find all multi-category tags in the view that we're looking at. We're also going to be looking at Genius Loki's create independent tag node. This is basically the node we use to create the tags at the end of our script. We're using 2.0.3 today. I recommend you do as well. I have found that some versions of Dynamo, the early 2s and before, don't behave the same way with some of these custom nodes. So without further ado, we'll jump in and actually start building our script. So I've got a model at the moment, and I basically want to tag everything I can see in the current view that has a valid field to tag. So essentially everything here except the walls and the doors. But imagine you had some families in here that you don't want to tag, which don't have the parameter as a result. Or maybe the parameter's there, but it's empty, for example. So we're going to find a way to manage those out. So we're going to start by finding all elements that are tagged in view. So what we're going to do is get that all view dependent families of instance. So basically the clockwork node. Sorry, that's not the one. I'll just search for it in here. All view dependent. I think it's this one here. No. There we go. So it's all view dependent family instances of category. It's important that we isolate the category because we want to get all multi-category tags. So we're just going to find multi-category tags in here. I've tried doing category by name with this field. Surprisingly, it didn't work. So I had to actually go and use this category drop-down node instead. I'm not quite sure why that's the case. So that was quite interesting. Anyway, so we're going to obviously add a Boolean just to toggle this to true when we run it. And then we're also going to take our view as current document active view. So we'll go current document active view. And keep in mind that my active view is currently set to that floor plan view. So you need to be in the view that you want to tag when you run this script. And I'll run this at particular stages just to start collecting data and show the data flow. So if I just start by running this, we should get all instances of the tags in that particular view. So you can see we have 18 tags in our view currently. So what we need to do now is find out the type of the view and find out if that particular tag is the multi-category tag that we want to apply. Because maybe you have different tags on elements, maybe you have two types of tags and sometimes you tag things twice. It's not very common, but it's still possible. So we need to get the element type. And we're going to flatten that list as well. Just because you'll see that this list is currently sitting at level 1. We just want to flatten that list out so that every element represents one item. There we go. So what we're going to do then is we're just going to create a string from object. And that's just so we can compare the type. So at the moment you'll see it's family type, multi-category tag, and my family's called multi-category tag as well, just to be extra confusing. What we're going to do now is take the family types node, and I'll just make this the multi-category tag as well. So it's this one here. And again, I'm just going to take string from object, and I'll do an equals node to compare and match whether those tags equal that particular type. And we should get a true if they're the same. And there you go. You see we'll get a match for all of them. I believe from what I experienced, you couldn't match up the family type with the family types. See, it gives me a false for all of them. Sometimes that happens in Dynamo. Sometimes certain elements don't match up with each other. I find that's very common with element types. So often I'll convert them to text instead because text is very easy to compare and match. But there you go. Now you can see they're all true. But what we'll do now is filter by Boolean mask, and we'll just filter down all those instances. So we'll go back to all family instances, and we're just going to filter based on this mask. Currently we've only got one type of tag that we're filtering for, but our outlist would basically remove all the tags that don't match that particular type. So what we need to do now is find the element that is being tagged by that tag. So we're going to use tagged element, which is an out-of-the-box node, and that will actually retrieve the element that that tag belongs to. So if we run this, we'll get a whole list of family instances. So they represent all the families that those tags belong to. Again, I'm just going to flatten this list because at the moment it's sitting at one level. I just want to make those all sit at the base level of the list. And we're just going to get the element ID of those elements so that we can compare them later on. Because really what we're doing here is just finding out which elements are already tagged so that when we go and find all the elements in our view that can be tagged, we exclude the elements that already have a tag from that list. So this is one part of our script done. That's the first part. The second part is that now we need to go and find out all the elements in the active view that are able to be tagged by the tag we're using. So we're going to use all elements in active view to find all the elements we can see. But now we need to find out if they have a valid field to be tagged by this particular type of tag. So we're going to go element get category or element category, because we need to filter out our rooms first, because we're going to get the type of these elements as well. And I found that rooms don't have a type, so they'll give you a null when you go and check their type. So if I run element type on this, you'll see I'll get a bunch of nulls, which I don't want in my script because users usually freak out when they see these and assume that the script is broken. So you'll see here, say element, I'll just zoom in a bit so you can read these. Element 146, for example, is giving me a null. So if I go and check out element 146, you'll see it's a room. So I'm just filtering these out because they're commonly in views. So we're going to use element get category, and I just want to get rid of all the elements that the category is equal to room. So we're going to do string from object to turn them into text. So again, easier to compare as text. And we're just going to be searching for a match for rooms because we want to get rid of these. You could do equals or not equals. It really just depends on how you want your in or your out for your Boolean mask to work. So we'll say not equals, and we'll set up a filter by Boolean mask. And essentially our in list is what we'll carry forward with, because our out list should represent all of our rooms. Oops. So if we go right down, you'll see that all our rooms have been filtered out of our data set. So what we can do now is proceed on and try to find out their type and find out if that type has a parameter value we can tag. So we need to get type. So we'll get element type. And the reason we're getting the type is because all these parameters we're trying to tag, they're not instance parameters, they're type parameters. So it's really important to get the type of the element if you want to get the parameter value of that type. I make that mistake quite often. I'll go and try to get a parameter value that's a type parameter out of an instance, and then I don't understand why I can't get the value. I forget that you've got to go to the type instead. So we're going to get parameter value by name. And the semantics are a little bit confusing for this particular node, because even though it says it needs an element's type is still technically an element in Dynamo. It's not an element type, it's just another type of element. Yeah, a bit confusing, isn't it? But that's pretty much how the semantics work. So I'm going to be searching for the values that relate to the parameter that I'm tagging on a multi-category basis, which is Aussie BIM Guru data code 1. So what I should get now is a list of all the codes, and you'll see that the first one has no code, for example. Same with 17 through to 21. So let's go see what 17 through to 21 are. My guess is they're probably walls or doors. So let's look at element 17. There you go. So you can see that we found some walls. So we know that we can't tag these elements because they don't have a taggable parameter. They'll give us a question mark. So we want to filter these out as well. So again, we're going to use a not equals node. So exclamation mark equals is not equals. And we're going to say, does it not equal an empty string, which is represented as a double apostrophe in a code block. So essentially we're going to filter these out of our out list. So we're going to filter our elements again. So we're going to take our list of elements and we're going to remove all those elements that don't have a taggable value. And if we go down and check out our out list, you'll see it's just consisting of things that don't have a taggable parameter, but also walls and doors. So really helpful. It's interesting to note that it looks like one of my families I thought had a tag actually doesn't. So in this case, my benches don't have a tag, which is interesting. I must have forgot that. So it's a good way to troubleshoot what you're actually going to be tagging as well. So there we go. Looks like I learned something too. Okay, so what we need to do now is get the element IDs of all the things we can tag, because now we need to remove the elements that already have a tag. So we're going to find something we can compare, in this case being our element IDs. Cool. So now we have a list of all the IDs of things we can tag and all the things that are already tagged. So we need to remove these elements from the list of things that we're dealing with. So we need to find out if the list of elements contains these items. So we're going to say, does this list contain these items? And we're going to be checking every level across level 2 of that list. Level 1, sorry. So for every element in this list at level 1, does this list contain it? And we should get a list matching the length of our taggable elements, telling us whether it occurs within this list. So we can see that we'll get a few matches here and there. We should get at least those 19 elements. You can see here they are. So we found our matches of elements that are actually not to be tagged. So we're going to filter by Boolean mask, and we're going to get rid of these elements. So based on this mask, we're going to filter out our elements back here. Cool. And now we know which elements we can proceed with. So we've removed those 19 elements, and we should have a few less now. So our out list now represents the elements that we can tag that haven't been tagged yet. Okay, so now what we need to do is prepare some data for the final node. So the final node is where we're going to create the actual tag. So we're going to get create independent tag. And I'll show you a few last things you'll need to do to prepare this node. So the node actually asks for quite a lot. It asks for the tag locations. So you'll need to give like an XYZ point where the tag's going to be placed. It won't just go to where the family is, unfortunately. You have to tell the tag where to go. As well as that, it needs a tag type. It needs the elements, the view, or the views that are being tagged in. The link instance isn't important in this case, and whether we want to run it. So the easy one to start with is yes, we want to run this. So true. I will freeze this node until we're ready to tag, just so we can keep building our script and running it up until that point. But a few things that we'll be able to connect soon will be our elements and their locations once we extract them. A couple of other things we can connect right now is our tag type. So we'll just go all the way back to our tag that we were checking for here and connect that up as well. And as well as that, we can also get our view as the active view. Way back here. You could also just create another active view node, but I prefer to only generate data once wherever possible, unless you're really complicating your script by pulling on elements from way back in the script. I think 2 is probably okay. I wouldn't do it too many times just to avoid confusing users. Okay, so what we need to do now is process our elements to get their location. So we're going to get element location. And it's important to note that some elements, their location won't always be represented as a point. These elements are typically things like line-based families, or also walls, for example. So sometimes you might need to process these out, because you probably don't want to tag these typically using this type of tag. But essentially we have dots representing the points of all of our families. In this case, I believe everything is a point. So what we're going to do is just build a little filter to get rid of elements whose location isn't a point. So we're just going to get string from object. So I think a really handy lesson that's come out of this lesson today is that it's good to convert things to text if they're hard to process for a comparison check. And we're going to be using string starts with, because each type of geometry will typically begin with its name as the type of element it is. So we're going to check if this string starts with point. So we're just going to use a code block, and I'm just going to do point as a string, and we'll ignore case. And in this case, I think everything is a point. But if you had a line-based family or a wall, say you had like a skirting that's a line-based family, you probably don't want to tag it because you're in floor plan anyway. So you probably just tag those separately. Okay, so what we're going to do now is we're just going to filter anything out that doesn't meet these criteria. So we're going to filter 2 things. We're going to filter the element locations and the elements themselves. And our mask in both cases will be this string starts with node. So one thing we're filtering is our location, and the other thing is our elements themselves from our out node over here. Okay, so then we're going to feed in our in result, which is the things that are true, so the things that are points for their location. So the first thing we'll take is our elements, and the second thing we'll take is the tag location. So essentially now we have a functional script. I also recommend hiding this element here and also this element here so that you don't see the points when you run the script. But pretty much at this point we have a script that should tag everything that's possible to tag in the view. So what we'll do is we'll just run this script and we'll zoom in so you can see it do its thing. So let's run the script. Run. Okay, I might refresh the script just so that it does what it's meant to do. Sometimes you need to refresh scripts especially if you're running elements that have like a refresh node or a true node when you run them. So I'll just cross-check everything's connected. Of course, my last node's frozen. Unfreeze, save, let's run. Cool, and you can just see everything's been tagged, but the things that can't be tagged, like walls and doors, are now excluded from the tag all. And you can see how quick that was. Now, obviously, you're going to have to move all your tags, but you've still saved yourself having to click and tag everything, or find all the elements that couldn't be tagged by a tag all. So you still saved yourself at least a little bit of time, especially in a large tagging job such as a major furniture plan. So hopefully that sort of is a helpful script and will help you save a bit of time in your day-to-day tagging. So there we go. For the real automatons out there, the people that want to fully automate this process as much as possible, you can actually tag more than one view at the same time. I'm experimenting with this at the moment myself, but I believe that the key to unlock this is the all element in views node from data shapes. And then you can feed that in the end to the Genius Loci node the same way. There will be a little bit of list management and lacing that you'll need in order to achieve the list management across the flow of the data, but I think it's definitely possible. So you could tag your entire FF&E series at once, and obviously you'd have to go and move all the tags after, but it's still faster than doing half of the tagging, right? Anyway, in the next video, we're going to look at how to tag all elements in view by room. This will be really helpful for looking at things like room layout sheets, where you only want to focus on one room of elements, and really helpful for room elevations, where you don't want to tag things beyond the extent of the room. So we'll look at that in our next session. So thanks for watching today. If you're not already following and subscribing, feel free to do so. And if you have any requests for future topics or videos, or just any comments, feel free to leave them down below. Always happy to hear from my followers or new followers. And I'll see you in the next video. Thanks. Take care. Bye.